So I'm Steve LeBlanc. I'm a sales engineer with InterSystems, and I'm here to talk about ICM, the InterSystems Cloud Manager. So in this presentation, I'm going to give kind of a quick overview of what InterSystems Cloud Manager is. I'm going to talk about our kind of native versus open strategy within our products. I'll go into it in more detail, but it's really we want to support a native tool to enable you to do something like cloud provisioning or interoperability or analytics, but we also want to be open and support some of the standards that people are generally using. So I'll talk a little bit about that. I'll give a brief technology overview, so just talk about how ICM works, what it's built on, and what the configurations look like and kind of the workflow. Then I have a quick demo. I've already started it just to spin up, provision some instances out on GCP, Google Cloud. And so I'll kind of walk through that and show the different tools, show an actual running container of ICM and the different command line options that are available. And then for the last 10-15 minutes, we have a guest speaker of Evan Bauer over here from OpStack, and he'll talk about what they do. So what is InterSystems Cloud Manager? It's a cloud provisioning and deployment tool. So it's really an abstraction to the APIs that spin up all of your various cloud instances, as well as configure your InterSystems IRIS clusters or your configuration. So it's declarative. So like Kubernetes, it's you're giving the end state of what you want your configuration to look like. You're applying it, and then the background scripts run in order to get your configuration to match that end state. It's infrastructure as code, so you have the ability to set up versioning around it. All of your configurations are defined in JSON files, and it for each cloud provider that we support, and I'll get into those. It handles the compute nodes. It sets up the underlying storage, the persistent disk storage on which the IRIS instances run. It sets up your networking or works within your existing subnets if you already have defined an environment. And it sets up some additional infrastructure services like load balancers and other tools. So really it handles the provisioning and deployment where you can define your configuration, your cloud configuration of an InterSystems application, create it, provision the underlying hardware across the various clouds, and run a full cluster solution via these JSON templates that ICM is made up of. So what clouds we support? We support the three major public clouds right now, AWS, Azure, and GCP. In our 2019.3 release, we'll have additional support for our Tencent cloud, as well as private. So we can work with vSphere via just the APIs provided there, as well as bare metal, like pre-existing configurations. Anything with an SSH connection, you can set up your environment that way. So we support both public cloud containers as well as actual bare metal and vSphere deployments. So I talked about the native versus open strategy, really. So our native tool at ICM, it's our native tool for provisioning and deploying applications in the various clouds. And I mentioned that supports, creates networks, creates the underlying nodes and storage. It provides a homogeneous interface. So, it's the template files that exist for each public cloud. It's all in a JSON template. I'll show you what it looks like, but it really abstracts the command line interfaces to each of the different public clouds to be able to define your machine type, your zone, your region, and all of the configuration options. There's some specific parameters that apply to each individual cloud, but as a whole, you can look at the various templates across the different public clouds, and it really gives you the ability to easily provision your full environment across them for testing and cost estimation purposes, without having to really go into the individual clouds and learn their full environment. And our QD department uses it very heavily, like every night, spinning up clusters to run all of our regression tests for our nightly builds of our IRIS platform and solutions. It's an effective placement strategy of where, placing containers. It's one container per node, because typically with a database application, you want like 95% CPU utilization of a node. So rather than putting multiple containers on a particular node, it's one container per node typically. We support containers, VMs, and bare metal. Anything with, you can SSH to an IP with a non-root account with sudo, then you're able to provision the environment using ICM. Now, moving to the open strategy, there have been some sessions on our Kubernetes support that we're launching. And actually, a lot of the work that was done to get our platform ready to be supported by Kubernetes is kind of rolled into ICM as well. I'll talk about that, namely the ability to declaratively define an IRIS configuration using the CPF file. You can specify a diff of what you want your end IRIS instance to look like with the CPF, and it actually just merges it into the default CPF, and I'll show an example of that. So Kubernetes handles the orchestration, the deployment and scaling, and some of the management of your clusters, but it doesn't typically, at least on its own, doesn't do the initial cloud provisioning. So ICM is aware where you can actually define what the cloud infrastructure is going to look like and spin that up. Whereas with Kubernetes, it's typically you're creating the underlying Kubernetes cluster. Some of the managed Kubernetes services on the various clouds provide some of that, but and Kubernetes is container only, so ICM supports some of the bare metal and vSphere deployments as well. So, not to say one is better than the other. It's like they're both good options, and I'm glad we're supporting Kubernetes. But just to show some of the differences, but they do have a big overlap in what you want to do. So, kind of tool of choice. So the technology stack, how is it built? ICM comes as a pre-configured artifact. It's a container you can pull from our repositories, our Docker Hub, our Docker Store, and it comes pre-configured with sample templates for all the clouds that we support. So sample GCP, sample AWS, as well as it comes with utilities for generating like test SSH keys and TLS keys. And it's just pre-configured to connect to those various clouds and run after you've defined your kind of custom templates for your configuration. It leverages, say, cloud infrastructure, lingua franca. It uses Terraform in order to do that initial cloud provisioning. And it's based on Java as well. It leverages multi-threading for parallel execution of creating instances and nodes and all the networking. So. It's infrastructure as code, as I mentioned, and it's all managed via these simple JSON templates. And I have some examples what that looks like. It comes with just right in the container that you start up. It has an intuitive command line interface. ICM provision to spin up your cluster and create all those networking and compute nodes. ICM run to actually apply your IRIS instance, or pull your IRIS images, run them. Install your monitoring tools and everything else there, and actually get your cluster up and running, as well as configuring things like mirroring and sharding for data partitioning. I mean, those are kind of manual tasks typically. If you're setting up a IRIS cluster, it can, you install 4 nodes, go from the first one, connect it to the second one, go into the second one, connect it back to the first. Then it can be complex. ICM lets you just specify, I want this to be a 8-node sharded cluster, and there you have it's all configured for you. And it's cloud agnostic, as we talked about. This one, it's repetitive. So the ICM values. So the simplicity that it provides, it's a simple JSON template. You can look at essentially 2 files. One that's defaults that tell you which cloud you're connecting to, what zones, and some like default usernames to the Docker, whatever Docker repository you're connecting to, and then a definition file where you're actually defining your IRIS configuration. So you're defining, I want 4 data nodes. I want those to be mirrored. I want a load balancer. That's all define in this definition file. Provides this abstraction that would let you easily change from AWS to GCP, simply swapping out some of the default settings in your file and running it on the various clouds, and that lets you verify performance across all the different public clouds very easily. And again, that's what our internal QD department uses every single night. And it provides full IRIS architecture support. So you can define just a single node deployment or up to really complex, like scalable sharding architectures, ECP, horizontal compute nodes, and data nodes, query nodes, depending on the architecture that you're spinning up for your application. Simple definition for I want mirroring. You just say mirroring true, and then it creates those extra instances in a different availability zone. And then can put an arbiter in a third zone to switch between the two. You can do multi-zone DR. We've recently added support for Bastion hosts, so you can spin up a Bastion host to be able to securely SSH into your kind of backend database infrastructure. Load balancers, and again, I mentioned the pre-existing configuration or the bare metal or VMware deployments as well. So I'm going to kind of walk through just the general workflow. Can't really see my mouse, but I guess I'll go walk over here. So you've got, step one is really you're baking your application image into a IRIS-based container, right? Then second step, you're defining just the basic templates for your infrastructure. So if you want a sharded cluster and you want to add a load balancer, and you can specify that in those templates. Then from the command line, running that ICM container, simply ICM provision, and that's going to provision the underlying compute nodes, the networks, and then install Docker everywhere that it needs to be, all that stuff. And then you ICM run to actually apply your configuration. That's going to pull your images from the repository, install, configure them for mirroring and sharding and everything like that. And then you're up and running. Anytime you need to make changes, declaratively make changes to your instances, you version your configuration files, make your change, run ICM run again. It applies those new files, spins up new containers, running the new versions. So it's really in line with this DevOps approach. And the actual management of your infrastructure from the ICM command line, you have access to through ICM SSH. You can get to the underlying compute node OS, right, and run whatever commands there. Just get into a Linux prompt. ICM session or rather ICM exec into the Docker container, running your IRIS image, and then ICM session to get right into an IRIS session. And some additional, this is all the command line options available. So there's the provision and unprovisioned ability to provision that infrastructure, the SSH and SCP utilities to get at that underlying OS, and then SQL. You can actually run arbitrary SQL commands or get into a SQL shell straight from the command line into whatever specified IRIS instance or through the load balancer. And then the run, stop, start, do the Docker commands, typical Docker access. Yeah, question?
Do you have the ability to limit, based on user ID, who can execute which of the different commands? In other words, you might want to use this front end for database, for DBA, to be able to get in and run SQL commands, but you wouldn't want them to be able to run maybe sysadmin commands, and vice versa.
Right. Yeah, I mean, it's so, I don't know the security aspect of.
I don't think so in the 2019
Okay.
release.
I mean, it sounds like a great tool. It's an easy way to get into the containers. It's an easy way to get into the command line inside the containers, but
The Cloud Manager is not the access pathway of choice for your actual end users.
Right.
This is for your operational folks to keep it up and running and provisioned and whatnot. The guys that are going to be doing your DBA work and looking in and poking around in the system would actually be dealing more directly with connecting to what they've been told is the touch point for that particular instance once it's deployed.
okay.
All right, so the last feature, I mentioned it before, but that new configuration state file, the ability to define a diff file for your IRIS CPF. So you define the file, you apply it to your ICM definition, this JSON template. You just reference that diff file, and then on the run, it's pulled in to be merged into the IRIS configuration as IRIS starts up. So you can change the default parameters and create new namespaces, things like that. And that's first available in 2019.4, which should be released in soon, this year or so. I'll move on to the demo. Before I get into like the architecture, I did start this earlier. So I have a GCP, just using the Cloud Shell here on GCP. I ran ICM provision. So look, I just log into my Cloud Shell, did a Docker run on the my pre-configured ICM container. So that came with just a couple of the customizations I did in my definitions file. That's all I changed in there. So pull the container, then I run ICM provision. I'll show you what my actual configurations look like, but that's going to go in and create these underlying instances, create the storage required, apply some monitoring, and install Docker on all these instances. And that's where I left off. So I've just got, here's my various machine names, the IP addresses, and their DNS, which availability zones they're all in. And then I'm going to do an ICM run. That takes a minute or two. But as I do that, I'm going to hop over to show you what those architectures look like. Let's see. So this would be just a single node, like a development architecture. So you've got the defaults file. That's got my GCP, my labels and tags, my project name, which is a Google-specific cloud option. Everything lives within a project, so I define that project. I define the regions and the various zones. I have multiple zones listed because I want to do like a mirroring configuration, at least in the next example. And then my password information, my Docker hub, my Docker repository, and you can use like secrets, and you don't have to have plain text passwords or anything. But this is just for an example, as well as like the Docker version and the actual OS image. And we support a few, like Red Hat or Ubuntu and CentOS, I think. And then over here, the definition file is my, it's just a single node cluster. So I want one data node. I'm pointing it to a license key and defining my machine type, just a small N1 standard. That's the Google-specific terminology for the machine types. It's going to be different in AWS. It's all, we document it, but obviously that's all documented through AWS as well. But what if I want to do something more complex? So I pulled this from, we have a GCP reference architecture for, just on our developer community of like potential deployments. And this is for a large, like a production level 4-node sharded cluster. It's mirrored, so you've got all of your 4 main nodes in one availability zone, mirrored to a second availability zone with a like the arbiter existing in the third, and we put a load balancer in front of that. I could also provision a bastion host, SSH into those instances. So what does that configuration look like? It's really, the defaults file over here. Nothing's changed. I think I changed the system mode so that the management portal would say live instead of this is a test system. But the definition, right here, we're defining, we want 8 nodes. We want this high memory, 8, I forget what this is, but it's one of the more expensive servers out on Google. I want to define SSD storage for my OS, for my data, the actual databases, and for my journal volume. So I can, I think the default is the standard HDD storage. But so I'm specifying here SSD. This zone map, which is what it's telling it the various zones for the mirror configuration. It's basically just saying use one zone for the 4 main nodes and a second zone for all the mirrors. Load balancer true. It's just saying we want a load balancer over this cluster. Mirror true. We want this to be mirrored into a different zone. And then I can define this user CPF. So this is that diff file. I just changed one of the default parameters as globals 16, just to show, that I think that's all zeros by default. So we're merging that into all the instances that we're creating. And then I'm defining, the arbiter below. But there's a bunch of different types of, either nodes or utilities like load balancers and bastion hosts that you can define through this file. All right, so hopping back here, let's hope everything ran. It did, so we did the ICM run. If I do the ICM inventory, I think it's that same list of all the underlying nodes that have been created, just in this. So in here, this is where my, oh, what did I do? I bumped something. Sorry about that. Okay, so I've got my, just within this directory, I've got my defaults file, my definitions file. I have my cloud credentials that I just pulled from GCP in this case. I created in GCP and pulled in, but you can do your Amazon ones separately, and then a bunch of logging. If I, step back, we've got the AWS, Azure, GCP. These are all template files with some sample configurations for any of these clouds, and it's just ready to go. You go in there, you modify those files, ICM provision, and it goes and spins those off. All right, so I've got access to my management portal through the load balancer. Once we spin this up, so I'm getting to this live system. This is our, just the first instance in our data node cluster. I can go in to the various settings. If I look at my sharding configuration, for example, we can see for the default namespace that I created that all of our shards are connected and they're all mirrored. So this is all set up for you. Again, this is that kind of labor-intensive, tedious process of setting this up manually. This is just all done via these scripts. If I pull up so I can SSH into any machine that I want. I'm just going to copy paste some commands so I don't have typos. So I'm SSHing into the machine for my first node, and if I want to look at that IRIS CPF file, I think it's IRIS. Scroll up, I should be able to see that we've pulled in that diff file. So these are all the settings that are in here. I only specified a couple, probably ran by it. Here we go. Yeah, we've got, it was there. Maybe you saw the 16 really quickly. I'm not going to scroll too much. I can, as I said, run just arbitrary SQL against these instances. So if I could session into the IRIS instance to get to just an IRIS prompt, I can also just get right into the SQL shell, which I'll do. All right, SQL interactive, and point to the machine that I want. I can also get to the load balancer. So here I'm at a SQL prompt. I'm just going to create a sharded table and throw some values into there, just to illustrate. Okay, exit. Oh, E. Sorry. And now if I want to just run SQL against the load balancer, which will hit any of those data nodes, and in the sharded cluster it'll bring back my full results. Right, I can get this result back, and you can see by the ID numbers that these were created across the sharded cluster. Right, they start at 1, then they start at 256, 512. So I won't get into the ID creation of shards, but yeah, just to illustrate that everything's all working as expected. And then I can unprovision my full instance from here. I can create multiple instance states, and they're all stored. There's a whole state file that's stored here. This is for this particular configuration, and I can unprovision that instance. I can have other instances running, etc. So that's the demo. Just to pull up, these are all the sessions that already went on at Global Summit, but they're all recorded, so you can check them out. So anything related to cloud and provisioning, there's the Kubernetes sessions as well. But yeah, so I have to hand off the presentation to. I get to hand off the presentation, but first I'll take questions.
I do have one quick question.
Do you want to hand over the microphone, just so it's recorded? And Anne's going to answer your questions.
Yes, it will.
And earlier you mentioned that it was capable of creating disaster recovery nodes as well. Is that geographically redundant, or is that within a certain group, like East Coast, or will that provision
Right.
an East Coast and also maybe a central DR site at the same time?
Right. So for multi-region support, I mean, you can't define it in a single configuration. So that would take an additional set of template files to put an instance into a different region. So at the moment, I don't believe we have the full. Are you gonna?
Actually, we'll talk about it in the next session, but you would provision each of them using essentially the same template files, and then you'd have to separately set up the replication after the two clusters were standing to put them into a DR config.
Which you could script, but yeah, as of now, ICM
Which
doesn't.
is, yeah.
Any other questions before I move on?
Right.
Yeah.
What would you need to do differently if you wanted to utilize this for on-prem?
Yep. So the config, if I just hop back to, and of course it's all documented, but container lists down here just gives you the, there's, instead of provision and unprovisioned, there's install, and there's links to, there's description files for the silent install of the instances. It's going to be a little bit just different parameters that you're setting to create these infrastructures, but working with, say, the vSphere APIs underneath. But yeah, so
Okay. And that would still work if you wanted to utilize containers, but still in an on-prem?
yes, yep. Anything else? All right, Evan, you wanna? I'll
Thank you, Steve.
pull up your slides.
This is just forward and back, right? On the,
I think so.
Great.
And I think I can full screen it if I
No.
remember where that setting is. Read mode.
There we go. Thank you, Steve, and thank you to InterSystems. Really glad to be here. And I'm Evan Bauer. I'm with OpStack. And it is a funny echo there, but better here? Yeah, a little bit. In any case, we're in the operations automation business. OpStack's short for the operations stack. All those components and tools that you need to layer up in order to manage complex applications and infrastructure safely and securely and efficiently at scale. And we like to talk about thoughtful operations, which is to say, instead of just react mode, which is where those of us who are sysadmins, DBAs, network admins spend too much of our time, to actually think it out and be part of the strategy, but also be part of leading the strategy. And what that looks like is that the backlog is understandable, so that you can, when someone asks you for a new IRIS cluster, you can tell them when they're going to have it. As doesn't necessarily, maybe it's instantly, which we've seen lots of that today, and maybe it's in the future, but if you're thinking about it, then you can make good promises and do that, and you can manage that backlog. That you no longer have to say, well, gee, if you want to expand the business, I'm going to need, into multiple regions, we're going to need to double the size of the team. Because when asks that, and I've never actually had a CIO give me the other part of the team that I asked for, so that there's just more systems and there's no more people to do the work. And critically, it's about having things be known and controlled. And particularly now that when you look at something like ICM or other automation technologies, when you're talking about infrastructure as code or software-defined infrastructure, that means that you can actually use source code management to manage that and be able to do it in ways that make sense and where you can always take that idle practice of going from a known state to a known state. And the final piece, which we actually aren't talking about much today, is that if you're a developer on a DevOps team, you're responsible for new functions, new value, new things that are happening. If you're on the operations side, you actually have to keep email running and the legacy applications, which are making sure your organization continues to exist, have to run as well. So you have to hit that piece of it when you look at there. We're a small company. We're a team of hands-on architects. I haven't committed any code since about 1 o'clock last night, and it did run this morning. But we're essentially out of financial services, and we're a new company of people that have worked together a lot before. But we're really here to talk about ICM. So I apologize for the infomercial, but our marketing guy will feel so much better that I said those things. That in looking at IRIS and looking at going from the cache world to the IRIS world and talking to our financial services clients in New York, we actually took a look at how do you build this thing. So we worked with the Ann and Harry and the team in the New York office. They provided us with licensing, and we tried out a tarball installation on RHEL 7 with and without the wizard, a Docker installation of a demo instance from the Docker hub, and then ICM, and did that, documented it, looked at it in terms of the light of the customers and requirements that we deal with on a daily basis. ICM. I mean, this was 2019.1, so 3 is out and 4 is coming. So that's but I can tell you is that it worked the first time, and it worked the first time we tried it with experienced DBA who knew the cache environment and was doing IRIS, but we also had it done repeated by a sysadmin who in fact had never seen an InterSystems product before, and it works. And it works the first time, which actually you can't say for doing an IRIS installation from the just from the pack. You have to work with it, and you kind of have to learn to play with the wizard and then see what comes out of the wizard and then run it again and do other things. We like the building on Terraform to stand up. That's the one. HashiCorp and the Terraform project is the one thing we've seen that actually stands up cloud infrastructure cleanly across multiple cloud platforms. Everything else is good on some clouds and not on others. The InterSystems team did a good job there. The fact that there's a single configuration file has pluses and minuses, but at least you know where it is, you know where to find it, you can get at it, and it builds it standalone or with containers, and does so in a way that lets you support really good agile development practices. One of the things that has been difficult historically for those of us who work with large databases is that you build a development environment and then there is and then QA and then UAT and then prod and then DR or whatever the stack is, but those environments tend to be long-lived. The result of which is that unless you're very, very careful and disciplined, you have configuration drift between what's happening in dev versus QA versus UAT and prod, and a great deal of time is spent in trying to get a next release or a code upgrade through those things. As the bits on disk that come up into memory and make the whole environment happen across many machines and in a cluster and many clusters across your organization, being able to make them ephemeral to the the overused Kubernetes thing is that, servers, go from being pets to cattle, right? and this really and ICM really lends itself to that. And there are both use cases and for ICM, and there are use cases for other approaches. And I want to try to sort of go at both of those to give some that. If you're creating IRIS instances for a new pure development environment and you want to spin it up and you don't want to invest any sysadmin, network admin DBA time on getting something in the hands of a development team, where there's a development DBA and coders, IRIS is, you can get IRIS out quickly this way and do so easily. It's particularly strong when the team that's responsible for the database is allowed to have control of all of the relevant resources. They're allowed to make network decisions, storage decisions, cloud billing decisions, because a full running IRIS cluster with a reasonable amount of data in it and some traffic is not an inexpensive thing from the cloud perspective. The good news is it's pay as you go, but the bills get to be interesting for everyone. It's one of those things, and the reproduction of identical environments across locations is there, and so so that you get to a build, test, deploy cycle, which for those of us who are ITIL true believers is a way of sleeping well at night. And you can use it as the basis of the IRIS portion of a large implementation, but as Joe's question about DR, it does a piece. It builds a cluster, and it at a time, and it builds it with specifically and exclusively the InterSystems components. So there's also, for every technology, there are use cases and counter cases. And the counter cases, and this is one of the part of what we were looking at was what would work where for our Wall Street clients. That although the Terraform piece is great, and it's a solid basis for what this does, but Terraform is fully wrapped. It's not exposed. So if you wanted to use Terraform to not just, and is part of an integrated build, not just to stand up, for example, software load balancers that are built into IRIS, but you needed to change the configuration on running F5 load balancers or NetScaler load balancers and add the database, the IRIS elements into those, which Terraform can do. It's not exposed because there aren't, by the time you use the ICM JSON, you're using the pieces of Terraform that are there, but it's wrapped, right? So it's so for the cost of additional complexity of using Terraform itself, you can get there. So it's ICM is IRIS specific. It's for the IRIS part. If you have other automation going on in your organization, and certainly when you look at banking institutions and the large fintechs, the people who we regularly work with, there is already automation around standing up environments, accounts, identity and access management, provisioning of those pieces, key management, use of HSMs or something like Vault, key rotation schemes, all of those pieces which would go into building, a production IRIS cluster when it's full of consumer or patient PII information that needs to be protected, then all those things need to be done outside of ICM, and might argue for using a similar construct as ICM, but making the InterSystems portion part of the larger picture, rather than handling it as a separate encapsulated entity. And some of that is an organizational decision. And then finally, although there's good control for the IRIS cluster from that ICM command prompt, When you start looking at the complex configurations of the other pieces of the software that go into your application, which may be your own application code, it may be working with identity and access management, working with switches and routers, in addition to just cloud-based, software-based networking capabilities. Then being able to use a more fine-grained programmatic control point, an Ansible or a salt stack. Those are the two. We're Python guys, so we really tend to go with Ansible and Salt. But Chef and Puppet are there for the Ruby people in the world. But those things need to be either wrapped, built around ICM, which doesn't actually provide an API. It's a command line tool, right? So you would have to then script the command line interaction, or to use the approach of this and build something different. So as you look at managing large clusters as part of large application suites, in the cloud or on-prem, that's sort of there are places where the power of ICM and its encapsulation of all the things that are needed for an IRIS cluster make great sense, and there are times where you would look at taking those same principles, and it makes a great guideline set for what you need to do to build and manage that IRIS cluster, but implement it in a more open tool set. So those are sort of the two approaches there. So that in looking at how you want to deploy IRIS in your organization, the ICM option is there. It is a superb place to get started with IRIS, right? But then you're going to need to look to enhance those things you do with ICM with monitoring, key management, process automation, security automation, right? Well, those are the pieces that would need to be added on, or you can take after you've gotten your development team started and you're working on your IRIS solutions, then look at orchestrating IRIS as part of your overall structure with a more open set of tools as an option as well.
Well, thanks everyone.
Thank you all very much.